Okay. All right, let's see. All right, well, okay, let's take a look. Let's try working through it. So we have A is this, right? B, okay, so like A is this, B points to the same thing. So we have B is this, and A also points to this, right? They both do the same thing. But then we say A equals new this. So what that means is that we have a new array here, and we're gonna delete this like arrow to this array, and put the arrow to this array instead. But B still has arrow to the same thing. So we change A's fourth value, right, or third or whatever, right, 2, so it becomes 2. But notice B's arrow, like the array that B points to, has not changed. So in terms of the values, it's A, you're right. It has not changed. It's the same as this as before because we never changed this array, right? All right. Any questions so far about that? All right. Cool. All right. So if you guys don't ever have questions, if you guys ever have questions, put it in the chat. Otherwise, let's go moving through. All right. For this one, which of the following is going to return null? Okay. All right. Well, yeah, let's go over this as well. Okay. Yeah. So this one's a little weird. So let's go over it. Right? So we have a matrix, right? And it's 5 rows, 3 columns. But what's important here is that we have like 5 elements, right? And each of those elements is itself an array, right? Because it's an array of arrays. So we have basically 5 arrays within matrix. So the 0th array we set to this. The first array we set to this. Second array we set to this. So what that looks like is we have like 1, 2, 3, 4, 5, right? And so in this one we have an array, right? And in this one we have an array, and in this one we have an array. This one we have an array, and this one we have an array. But the thing is that arrays themselves, if they're defined, like arrays may have no elements, and in this case, right, the arrays don't have anything in them. But the thing is that these arrays are something, right? So they take up some value in memory. So what that means is that none of these entries is actually null, right? It's not null because there's value there. It's an array. So when we do matrix 0, okay, matrix 0 obviously is a null. Matrix 1, 2 isn't null because we actually set it to, it's going to be 0, right? Because this is new in 5. So the default value of an integer in an integer array is 0. But in this case, what this does is it actually defines an array of arrays. So each of the elements of our original array is an array of 3 zeros, right? So like what happens here is that like matrix 3 and matrix 4 aren't null. They actually have a value, right? They're just arrays, empty arrays, but arrays or default arrays. Okay. So this one's tricky, but it actually is E. And to me, this is one of the hardest questions on here because it's like, it's really weird, right? All right, hopefully that makes sense. Okay. So for this one, which of the following is going to return null? The rest of you can all put your guesses, but. All right, cool. Yeah. So you guys are right. This one is D. Yeah, because in this case it's a little bit different, right? Because we didn't define the second element. So right now, like yes, we know it's going to be an array of arrays, but the problem is this array, like we haven't defined it yet. So remember, the default value of an array is null. So if we don't give a default, like we don't put how many columns there are, right? It doesn't create the array for us, right? So right now it's just like null, it's just the default array, which is null. So we still have 5, right? 1, 2, 3, 4, 5, right? But right now these don't like go to anything, right? So the default value is just null. That's why it's a little bit different in this case. So matrix 3 is null. So that's why we get that. Matrix 0 isn't null, right? It's defined. Same thing with matrix 1, 1. It's just 0, right? Because default values inside of an integer array are 0. So this new int 6 means we have an array of 6 zeros, right? Same thing for 2, 1. Okay, so the only answer that is left is D. All right. Yeah, as I said before, if anything doesn't make sense, just go ahead and stop me. All right, so next question is, what is the output of this program? All right. Yeah, so you guys have it right. So it is A. And the reason why it's A, well, let's go through it, right? So you guys have it exactly right. You have an array, right, and it has 4 values. So let's draw that out. This is ARR. AR0 is an array of 2 elements, and the default value of an integer array has zeros. Okay. And then we say, okay, AR1 equals AR0. So it doesn't just it doesn't copy the values because they're both arrays. So they both just point to the same place. Okay, so we go ahead and change the first element of AR0. Right, this is AR0 right here, right? This is what it points to. So what we're going to do is we're going to set the first value to 3. So we do change it from 0 to 3. And then we go to AR1. And that happens to point to the same place as AR0. So when we change the first element, or the 1th element of AR0 and AR1 is the same, right? Like they're like 1th elements because they are the same array. So we go here, we go 1, we go 1, and we change this to 4. So now we go through AR0.length, which is this one, right? We're going to be going through this array, right? So we're going to print out 0, 0, 3, or no, 0, 0, and 0, 1, which is just 3, 4. So you guys got it. Very nice. Awesome. All right, so for the next question, reversion control and exception. Yeah, so this one, what did you guys get? All right. Yeah, so you guys got it exactly. That's exactly right. If you want to stage your entire directory and all the non-empty directories inside of your current directory for a commit, right, you use git add dot. So this like stages it for the commit. So first you have to add, right? And so git add dot allows you to add all of them, right? So that is the syntax we use. Yep. Okay. So then for the next one, which is the following is not correct. C and 0D. And so let's go through them. So first, the commit command is used to save your changes to the local repository. That's exactly what it's for, right? Commits are local until they're pushed. That's definitely true, right? Oh, what's in that? A clone operation makes a copy of a repository locally. Yep, it goes from the remote to the local, right? So that's definitely not it. But yeah, D, it's a push operation doesn't pull changes. So what will we have to change the word push to make this sentence true? So yeah, sort of, right? Like that's pretty close, but yeah, you got it, Jacob. Yeah, it's a pull. So like clone and pull are like similar, but in this case, like the reason why we would say it's a pull is because it says pulls down any changes. So in general, right, when you clone it is when you first like make an instance of the repository, but then when you want the changes, right, that's when you pull, right? So it's a kind of a subtle difference, I guess, but yeah, that's all right. So what's the output of this program? I'm trying to zoom out a little. Yeah. Yeah, as you call people said B. So let's check it out. So we try int num4 equals 0, right? Or int num4 equals 4. Int num equals 4. I don't know why I had so much trouble saying it. Yeah, but okay. So far so good, right? We're into the try block, no problems. The next line, num equals integer at parseInt. Interesting. Well, interesting isn't an integer, right? So it's going to try and do that, and it's like, oh, I can't turn interesting into a number. It's not a number, right? So the try is going to fail. It's going to throw an exception, so it'll go into the catch block. In the catch block, we throw an exception. Or no, we try and catch an exception, right? Because the exception was thrown here. So we try and catch an exception. There's an exception. It's of this type, because all exceptions are a type exception. And so that just does whatever in the catch block, which in this case prints out something wrong. And so that's all we get. So it's B. All right. All right, so next, now that we're done with reversion control and exception, we're going to the next module, which is about classes. So yeah, so let's take a look. For this question, the return type of a mutator, like a setter, the return type of a setter for the height instance variable is, oh, looks like I missed a question, so sorry about that. Yeah, we'll come back to this one in just a second. Yeah, so do we have to know different types of exceptions or just how to try their catch works? So like the thing is that you might need to know like a couple simple exceptions, like you might need to know like if you might be able to have to recognize like the type of exception it throws, but usually it's kind of self-explanatory, right? Like if it's a input mismatch exception, right? That means there's an input mismatch, right? So usually there isn't too much guesswork. Like for example, you might have like two different exceptions. So you might have like or two different catch blocks, right? So one is just a standard exception, and one is like input mismatch exception or something like that, right? I don't know. I haven't actually looked at this year's exam, but like I think we had something like that on the exam review last year, where it was like two different exception types. So, but like the thing is it was a common type of exception, so something you'd probably seen before, and it was just you had to know whether it was an input mismatch or not. But it was like something kind of obvious, hopefully. Yeah. Yeah, exactly right. The specific one does have to come first. That's exactly right, Sam. Because if it doesn't, then it's just going to go to the regular exception one. So yes. All right. So back to this question. Yeah, so let's see. The thing is that, right, you have getters and setters, right? So a getter returns some value. So when you want to return a value, right, then you're going to have the type you want because it has to return that type. So in this case, if you want height, right, it's going to return it. But it's not asking for the getter, it's asking for the setter. And in a setter, right, you don't have to return anything. You're just setting a value in the class. So it would look something like this, right? It would look something like set height. And I take in a value int h or something, right? But it's not returning anything. And what type do we have when we don't want to return anything? We have void, right? So that's exactly right. Yeah. What you said was exactly right. It is void. So hopefully that makes some sense. And I guess we'll keep going, right? So the output of the following code is kind of some long code, but we can take a look at it. Let's see. Yeah, so that's okay. As I said, this question is like, it's a lot, it's trying to pull a lot of different things into one. So like, it's a little bit of a tricky question. Okay, it's a lot of a tricky question, but we'll look at it together because it's weird, right? Okay, and it's really weird, I think, because like, for example, you're inside of the student class, right? And you're inside of this class and your driver is inside of this class. So your main is also in the class. So it's really weird, right? Because you're trying to basically make a student inside of the student class. And it's weird that you can do that, but you actually can do that. So it's a thing you can do. Like I've only ever done that once, and it was for a project for one of my classes. I learned that last semester you could even do this. So it's like weird, right? But it's totally something that's fine. Um, yeah, but it's just weird. So okay, we'll go through it though. So first make a grades array, right? And so our grades array is 85, 80, and 90. So let's take a look, right? Let's just make our array. So grades is something like this, right? 85, 80, and 90. All right. Next thing we do is make a student Bob. And the reason why this is okay that we have this in the same class is like, this is a static method, right? So it doesn't actually belong to a particular object, but rather that like, it's just a method, right? So it's not something that's like belongs to an object. So it's perfectly fine that we just have a student, right? We can still make a student and it doesn't have anything to do with main. All right. I mean, you probably could call like bob.main, but that's really weird. So I don't really know even know why I mentioned that. It's not something you'll ever really deal with. So on in the exam or otherwise. So anyway, so we make Bob, right? So Bob, just call it B, is a new student. So it creates an instance of a student and it calls this constructor, right? And it passes in an int G. So we have a new student. So we have a student, right? Whose grade value right now is grade sub 1. Well, grade sub 1, we have 85 and then 80 is grade sub 1. So his grade right now is 80, right? So far, that's what we have. All right. Okay. And the next thing we have is grade X. So grade X. And grade X is grade sub 2. That's just 90, right? Okay. So far, that's what we have. And then we call increase grades. So increase grades is static, so we can call it from main. It's in the same class. We're fine. So we call increase grades. We pass in these values. So we pass in grades, we pass in Bob, and we pass in grade X. So all three of these variables are the same. We do grades sub 0, we add 25 to it. Okay. So remember, when we pass in, let's actually go through this because these are our values, right? But this isn't the whole story. So we call this method, right? It doesn't copy over the values of grades. It is grades, right? Like this is the same thing because arrays are a reference type. Same thing with student, right? So this student is the same thing. It points there. But for primitive data types like int, it just copies the value. So for int grade, instead of being this particular, does that say? Oh, it says 90. Okay. So instead of being like grade X, right, this just copies the value. So this is just equal to 90. It has nothing to do with this variable. So let's go through it, right? So we set grades of 0, we add 25 to it. So what that does is it changes grades of 0 here from 85 to 110. And then we make student.grade 100. So we're going to change the grade of B here, right, to 100. And then we're going to set grade equal to 101. So we set this value to 101. So notice, G and B are the same variables we have in our main. But gx and grade here are different variables because this one's only in this method, grade is only in this method, and gx or grade x is only in this method. So we call increase grades, and afterwards, we look at our changes to our original variables, gb and gx, and well, two of them changed. So when we call our print statement, when we do our print statement, right, we do grade 0, we print out grade 0 plus bob.grade plus grade x. So we're printing 90 still, right? 90 plus bob.grade, which is 100, plus grade 0, which is 110. So we have 110 plus 100 plus 90, and that's 300. So we get 300. Okay, and that's it. That makes sense? Yes. Cool. Okay. Awesome. So let's go to the next question. So we're given the following class definition. Hero, string name, okay, yeah, that's all. So assuming this is our main, right? What do you guys think is gonna happen here? All right, so yeah, let's go over this one. Okay, so the first thing we do is make a hero gym. Hero gym, new hero, name is Jim, and number 12. So like one thing we usually do is we just write out the private attributes. For this question, I'm just not going to write it because we don't really need to know the private attributes of each variable. Okay, actually no, I'll go ahead and write everything out because I think it's good practice, I guess. So okay, or like good for practice, not like good practice. Okay, anyway, so we have Jim, right? So let's just call it J. Name is Jim. Jim. Power is 12. And so these are its private attributes, right? What's important to notice here is this static hero count is static variable. So what that means is that it doesn't belong to a particular object. So rather than having one hero count variable for Jim, we have a hero count variable for all the heroes. So rather than just assigning it as a private variable of Jim in particular, because it's not, we're just gonna like write it out here. We're gonna write hero count out here because it doesn't just belong to Jim. Okay, so when we call our constructor, right, we set this.name, this.power, but then we also increment hero count. So hero count here now is, well, for the hero class, is 1. Okay. So next make a Pam. Pam name is Pam. Power is 9. And again, we call our constructor. So we increase our hero count to 2. Okay. Then make hero Andy. So Andy, A, and N equals Andy. Power equals 4. And again, we increase our hero count, right? Let me just erase this and write it again. Okay, so now our hero count is 3. So far, so good. Then we do Jim.HeroCount minus minus. Well, We can do that because it's like, this is relatively public, right? I mean, it's package protected, but essentially, if we don't put a type, it's basically like it's public. So this is basically a public int. So it's not even a private. So we can totally access it like this. That's okay. So when we do that, we just decrease the hero count. But the thing is that we can do this because it is like Jim has access to hero count. But hero count doesn't just belong to Jim. It belongs to all of the heroes because it's static. So we're still changing this variable, even though we call it on Jim. Then we make a hero Aaron. So Aaron, n equals Aaron. Right? And power is 10. And then we say here Michael. So Michael, n equals Michael, whatever. Yeah, just too long to write. And power is, okay. So then we do Aaron.depth 2. So on Aaron, right, we're going to call the depth method. And all the depth method does is it looks at our, oh, I forgot to, sorry, when I made Aaron, I forgot to increase this to 3. When I made Michael, I forgot to increase it to 4, right? So that's what we have so far. When we call Aaron.depth 2, that goes into this method for Aaron, and it just says, okay, decrease the hero count by 2, or by death count, which in this case is 2. But remember, hero count is a variable of the type, right, of hero, not of a particular object. So even though we're decreasing the hero count that Aaron has access to, the hero count that all of the objects have access to is the same, right? Like, for example, if I wanted to do, well, okay, we'll see this in a second, right? So I'll just forget I said anything just then. But yeah, like we do Aaron.depth 2, so it decreases our hero count by 2. So this becomes 2. And so then when we go to print out hero count, we're gonna get 2. And we can do this, right, because it's a static variable, and static variables belong to a class. So because it belongs to a class, we can call it on the class. We don't actually need to use an object to get access to it, right? If this weren't static, then we can't do this, right? You can't, it doesn't, if it's not static, it doesn't belong to a class. So you can't just call hero dot. So variable, because it is static, it belongs to a class, not a particular object. So we can do this, or if we wanted to, we could have done like, for example, Aaron.heroCount. If we did like, or Jim.heroCount. And for any of those, it's going to be the same variable, right? Because all of them are the same because it's static. So all of them would print 2. And in this case, hero.heroCount, still 2. Okay. So that's a good question. And the answer is, yeah, we actually, well, yes, we can, because it's static. So that's a good point. This is static, right? So if we wanted to, we could call hero.depth, right? We don't necessarily need Aaron. Good point. So we could call hero.depth and then some value, like 1 or something, I don't know. Or in this case, we want to do the same, we could do 2. So you're exactly right. Yep, that'll give us the same result. Good question. We still need to call it on something though, right? So we'd still need like hero. But yeah. All right, hopefully this makes sense. We'll move on. And as I've said, if you guys have questions, just put them in the chat. All right. Or you can speak if you want. That's perfectly fine too. Okay. So what's the output of this program? All right. All right. I see someone put error and someone put 0. So the first question is Linda. So why did you put error? Yeah, that's exactly it. Yeah, you got it. Yes, this was like really tricky. Like when I first looked at this one, I did the same thing. Like I was like, oh, well, I mean, it's 0, right? Like there's not anything set yet. But then I looked again and I was like, oh wait, so I guess, yeah, that it must be an error, right? Because there's no default constructor. And yeah, it's tricky, right? It doesn't look like that this is the issue, but it is. So when we do, we call the constructor here, right? And here we've written a constructor, but it takes an argument. And if you write a constructor that takes an argument, you can't call a no argument one anymore, unless you write it explicitly, right? Because it's only provided, like this no argument one is only provided by default if we don't write a constructor by ourselves. We wrote a constructor, so this one isn't available anymore unless we specifically write it. So by calling it, we try and call it, doesn't exist, we get an error. So D. Oh yeah, that's okay. I get that. Yeah. So yeah, this one's there. Right? Okay. So for this next program, it's kind of long as well. Let me take a look. So what do you guys think? All right. So right, it's the same code as before, right, for Apple. So all right, let's see. And I'll answer all your questions as I go. So it's 14 converted into double. So yes, 14 is integer. An integer can always be like, if you pass in an integer and it's expecting a double, that's always okay, and it'll just turn it into a double. So good question. Yep. If you try and do it the other way around, right, you try and pass in like 14.5 and it's expecting an int, like that'll be a problem. But okay, so let's look. So we make a new apple, right? Fuji, so let's write Fuji, right? Or something like that. And its weight is 14. So we say public apple double weight. So this dot weight equals weight. So that means our apple's weight we set to 14, right? That's what we have here. Okay. So it's good. Let me say print Fuji.getWeight. Well, for Fuji.getWeight, we just return the weight. Fine. We do that, we print it, it's 14. Okay. Then Fuji.setWeight 3. So this with my highlighting, you may not be able to see it, and that might have thrown some of you off. But this does have an underscore before it, but it may just look like it's double underscore for the blue. But in any case, when we call Fuji.setWeight 3, what that's saying is that it passes in the value 3, and so it sets the weight that belongs to the Fuji, right? Fuji equal to whatever's passed in here. Well, 3 is passed in, so we set this weight equal to 3. And then when we print it, we're going to print 3. And it's kind of weird because, right, this is an underscore. If this underscore weren't here, right, and this underscore weren't here, then it would be 1414, right? Or no, sorry, it'd be 1414. Because in that case, we would be setting, like, it would refer to this weight. So it'd be setting this weight to itself, which doesn't do anything because this is the weight that we care about, right? This one is only accessible inside the method. But because the underscore is there, it's able to differentiate between the two, right? It's able to differentiate between this weight and this weight. So it actually does set the weight of the apple, of the Fuji apple, right, to 3. So it is going to print 14 at first, and then it's going to print 3 afterwards, right? All right. And I guess technically, when it prints, right, it's going to print 14.0 because it's printing a double. But I mean, 14.0, it's the same idea. So, and I guess it'll print 3.0. But yeah, like whatever, 14 and 3. Yep. All right. So hopefully that makes sense. And we'll go to the next question. Okay, so we haven't really gone over inheritance, but it is an exam. So there are a couple of tricks, I think, for inheritance. If you guys do these problems, great. If not, like there are a couple of tricks I think that really help. So we can go over those tricks. Yes. Yeah. Inheritance is like really, you can't say inheritance and like, it's just so different for everything else. I don't know. And every semester I have to like think about it again. Like, how does this work? But okay, so I think it might be best, like, unless you guys have done all these, but even then, I can just go over all of them one by one. We can kind of go through them and see what's going on. Because I think inheritance is like probably a good way to go about that. Okay, so in general, right? Okay, well, first let's like draw out what this looks like. So we have A, class A. So A is top. Well, above A we have object, because every object derives from object. So every class extends object implicitly, even if you don't write it. Every class does extend object. So we have A extends from object, B extends from A, C also extends from A, and then D extends from C, and E extends from B. So that's what we have. This is what it looks like. Okay. All right. So that's the first thing. I think it's important. Like sometimes maybe drawing it helps. So let's do that first. And okay, so the first thing we have is A my class equals new A. So to see if a statement is valid like this, what helps is we can read it from right to left. So read from right to left and read it basically in our heads like this. A is an A. Because the type is A, right? A in my class equals new A. So we say A is an A. And then we see, is that true? So is A, like A is an A. So if that's true, then A is either equal, like A is the same type, or A is like one of the ancestors, like a parent of A, or a parent of a parent or something, right? Well, in this case, right, A, you can write A my class equals new A because A is an A, right? So for example, if I had like type animal or something, I don't know, or student, right? If I had student or something, right? Student equals student, like that's perfectly fine, right? A student is a student. So this line compiles and works just fine. So this is fine. Okay, let's look at the next one. So this one's a little tricky, right? So the first thing we have to do is we have to go from right to left. We say E is E and E, right? Right to left. E is an E. So this line is fine. So my class is E, right? So we have to say basically like E is a B. So is E a B? And the answer to that question is yeah, it is, right? Exactly. Because here, every E extends from B. So E is a B, right? Like every E is also a B. So this is okay. We can totally do this because E is B. For the second one, which E is it? It's referring to this E, yeah. And like each of these statements is like on its own. So like this, like A here is by itself, B is by itself, C is by itself. Oh, C, T, T, or sorry, what do you what do you mean by CTT and RTT? Oh, runtime type and compile time type. Sorry about that. I just realized what you meant. Yeah. Sorry. Compile time and runtime. Yeah. Okay. Sorry. Yeah. So exactly. Yeah, that's a good question actually. So okay. Yeah, let's look at that. So here, right, the compile time type is going to be E, and the runtime type is also E in this case, right? For my class. And for next class, the compile time type is B, but the runtime type is E. But we're going to get more into that, what that means later, but yeah. But yeah, I mean, it's good that you guys know, but I meant like, we'll go over some more examples with specifically compile time type versus runtime type, but it's good. Yeah, it's good we look at that now, right? So the compile time type of this is E, right? And the runtime is also E for the first line. And for next class, compile time is B and runtime is 1. All right, so for the next one, we look at, and oh yeah, one more thing I think that is good is usually when we're looking at compile time type is determined by what's on the left, and runtime type is determined by what's on the right. So in this case, right, the left side for next class is B, so compile time type B, and what's on the right is E, so runtime type E. And in this case, both are E, so compile and runtime type are both E. All right, so A works fine, B works fine. Let's check C. So C, my class is new A. So we read it from right to left. We say A is a C. Is A a C? Right, yeah, it's not, right? We can look at this tree here and we see, okay, C is an A, right? C is an A, but not the other way around. Right? Not every A is a C. So we can't say that. So that's no. Okay. So the next one, we have object. My object is new E. So the first thing we have to do is just have to say, okay, is E an object? Yeah, it is. And it doesn't matter that it's like not directly, right? Like object is way up here and E is way down here. But that's perfectly fine. Like in order to extend from it, you just have to be below it in the tree. Like not just below, like for example, like D is below B, but they're on different sides, so that would be different. But in general, right? Like if it's below it, but you can like go up the tree to get to it, to go from E to object, then it extends from it, right? And every object extends from object. So yeah, this is perfectly fine because object, my object equals new. So E is an object. So this is fine. So it compiles. Okay. So next one, we have B other class equals new C. So we have to read it again, right to left. We say C is a B. And is C a B? Yeah, that's right. It's no, right? And it's no because, again, they're on different sides, right, of A. So you can't just go straight from, like we have to say C is a B. So you can't just go up the tree here, like up to get to a B. You'll never get there, right? It's on another side. So like C is not directly below B anywhere. So it's not, C is not a B. Okay, so for the next one, we have a few lines. So the first line is object my class equals new A. So the first thing is A is an object. Is that true? Yep, so this line is fine. So for the next line, we have, this is where compile time type, runtime type are important. So first, let's see, what's the compile time type of my class? Compile time type, remember, is defined or is determined. Oh yeah, right. Yeah, compile time type is determined by what's on the left, right? So object, right? And runtime type is what's determined on the right. So what's the runtime type of my class? Exactly. Yeah. Nice. Okay. So on the next line, we try and cast my class to an A. So when you're trying to cast, what you have to make sure of is that when you're casting, what you're trying to cast to is what that object is, right? So in this case, right, we try and cast my class to an A. So based on, and that's a term based on the runtime type. So basically it checks the runtime type and it says, okay, it tries to say my class, if you can make my class into an A, so basically if my class is an A, then that's perfectly fine. So here is my class an A. Like, well, okay, based on the runtime type at least. Yeah. So yeah, it is, right? Because the runtime type of my class is A or above it, right? So when we try and cast, you have to make sure that the runtime type of that object is either at that level, so it's either at the level you're trying to cast, or it's above it somewhere. And in this case, it totally is, right? We say A second class equals A my class, and we can do it, right? So that's perfectly fine. And we can do that because my class is an A based on runtime type, right? So we can do this, we can cast it, and this is also fine, right? Okay. Okay, so let's go to the last one. So A third class equals new C. So we have to read it again like this. C is an A. And is that okay? Yeah. Mm-hmm. So perfectly fine. Awesome. And then the last line is C next class equals C third class. So we're trying to cast third class to C and then setting next class equal to. So can we cast third class to C? Yep, exactly right. Because the runtime type of third class is C. So we can cast it to that. And we know that because C is on the right here. Cool. Oh yeah, nice. Okay. So right, so this is perfectly fine. And C is, and we read it from right to left again, right? And just make sure. So we have C on the right, right? Because we've casted this to a C, we're allowed to do that. We have C is a C. I mean, that's obviously true. C is a C. So this is also okay. And so, okay, that's what we have. Right, so hopefully that was kind of clear. Yeah, then we'll get to more practice with this in the next questions. Okay. So for the next question, okay, so this one, all right, this one's fun. Oh, that's a good question. All right, so we can't cast third class to A or object. So that's a good question. You would have right. So yeah, technically you could cast third class to A or object, but the problem is you can't assign it to next class C, right? Because then you'd have A is a C, which wouldn't be true. But you, like, if this were by itself, you could totally cast this to like A instead of C, right? But you can't have assign a C to it. Good question though. All right, so for this one, the output of the, I guess it's below program, not above, but oh. I want to make sure that we have time for the free response questions, so we'll just start going through this one together. And yeah, so let's start going through it together. Or if you guys haven't answered, okay. All right. All right, so the first thing we do is we have fish. So make fish equal new fish. And so we go into the fish class, we see, okay, there's just a default constructor, right? There's no constructor provided, so there's just a constructor. So we have fish, right? And fish has a weight, right? And weight is originally just equal to 0 because we didn't define it. So it just gets the default value of 0, right? Because it's a class variable, so it gets the default value. Let's see, I can't write a 0, so I'm just gonna write this as 0. Okay, so far that's what we have. The next line we say, okay, salmon is a new salmon. So we go into the salmon class, we look at its constructor again, constructor just has default 1. So the important thing though is a salmon extends a fish. So it gets everything that a fish has as well, right? This int weight is not private, so it doesn't just belong to the fish. It also belongs to salmon. So we have salmon also has weight 0, and we'll also have home. It also has a home variable, which originally is just null, right? Because default value of string is null. Okay, then make another fish, Mike, equal new salmon. So when we do that, right, it's gonna basically make a salmon, right? Because we're saying new salmon, so still make the salmon. So we have Mike here, but he is a fish. So Mike here, like his compile time type is fish, but his runtime type is salmon. But he still has like everything that a salmon would have, right? 0, age equals null. And so far, so good. Then we call salmon.swim. We call salmon.swim, we check first. Does salmon have a swim method? And it does, right? And so does fish. But in this case, what happens is that salmon is a salmon, right? Its runtime type is salmon, and its compile time type is salmon. So the first thing we have to do, with this, we have to check first. Does the swim method exist in the salmon class? And it does, right? It exists in the salmon class. And then we can call it. And it's okay, we just print splish splash, right? So splish splash. So that's what we have after salmon.swim. Then we call Mike.swim. So the tricky thing is about Mike is, remember, his compile time type is fish. So what we need to do first is we need to check in the fish class, is there a swim method? And there is. So this line compiles just fine. At runtime, what this is going to do is it's going to use the runtime type. So first, compile time type, it just has to make sure that it's possible, right? That the compile time type has access to it. But at runtime, we have to make sure, well, at runtime, we're just going to use the runtime type. The runtime type of Mike is salmon. So it's going to use the same method as before. It's going to use the swim method, right? It's going to, again, print splish splash. But the problem is with the next one, right? It's going to call Mike.swim 5. So at compile time, we check to see, we have to make sure first at compile time that we can do that. Compile time type of Mike is fish. So we go into the fish class and we make sure that there's a swim method that takes a variable. And there isn't, right? There's no such method because the only swim method here doesn't take a variable, doesn't take a parameter, right? So this isn't going to compile because it's going to be like, oh, Mike is a fish at compile time, and there's no such method in the fish class. So it's going to throw an error. Yeah. So there's an error. So okay, let me check. So 1 second, I'll go through the questions. So if compile time type and runtime type are different, we go from general to specific, making sure each method is yes. So the first thing, great. So exactly inside of the, if its compile time type and runtime type are different, you have to check its compile time type before the method, like before it compiles, right? You have to make sure that the code will compile. And if it compiles fine, then you only use, like when the code actually runs, you're only using the runtime type, right? Because that's all that matters when it's running. But when it's compiling, you have to make sure it actually compiles. So that's what we do here. So how we would fix this, right, is we want to make sure that the compiler knows that Mike is actually a salmon. So we can do that. We can just cast Mike to a salmon. And we can do that because Mike is a salmon, right, at runtime. So there wouldn't be a problem. So we can cast Mike to a salmon. We can do salmon Mike dot swim 5. And if we did that, then we'd be fine, right? Because that's telling the compiler, hey, turn Mike into a salmon. So the compiler is gonna be like, okay, let me check the salmon class. Yep, this exists in the salmon class, so you're good. So the compiler says, okay, you're good. At runtime, it checks, okay, is Mike a salmon? It is, right? And then like, it just runs it, right, with Mike as a salmon. So how to fix the compile time problem is we cast. Okay, so when do we need the add override? So add override, I think it's just provided like by IntelliJ. But override in general, right? You override a method if you want to rewrite it inside of this class. So here we're actually overriding the swim method inside of the salmon class. So this is you don't ever need to write override because it implicitly overrides, but like sometimes it's nice for markup to see, or I don't know if it's markup, but like it's nice to see, right, that it's actually overriding. But for example, this method here is overriding this one. No problem. All right, so yeah, hopefully this makes some sense, right? It doesn't compile because there's no such sim class or no such swim method inside the fish class. Make it a fish. I compiled. But if it compiled, then it would be fine. Like at runtime, it's fine because such a thing exists. So just we have to get it past the compiler. So that's why we cast. But I think the next question, maybe it's 2 questions from now, should clear that up a little bit more. So let's keep going. Unless you guys have questions about this. Okay. Yeah, so no, yeah, they're just fine. Okay, yeah, so this one I think actually should help clear things up quite a bit. I think this is a good question, just because it kind of helps explain everything, or like shows everything a little bit. Okay, so let's again, let's just do this again, where we have the different layers, right? So the first thing is the top layer, as always, is object. Below it is person, right? And below that we have student. Okay. And here we have person A, person B, and person C. Yeah, they did. Okay, so let's just first write out the compile time type and runtime type of each and every person or object or whatever. So, okay, so what's the compile time type of A? Person, right? Okay, and what's the runtime type? Yep. Okay, and then for B, compile time type is, yeah, person is student, right? Okay, so we're just gonna write that out. Compile time type is person, and runtime type is student, right? And for C, I'll just go ahead and write it, but yeah, you guys, it seems like you guys got it, so it's good. Compile time type we get from the left, right? It's an object, and runtime type we get from the right, and it's a student, right? So I'm just gonna separate them with a line here so we can see. Okay, so the first thing we have to do here is we have to do the first line, right? So do a.print type. So in order to do this, right, we first have to check, right? Does the print type method exist in the compile time type class? The compile time type is a person, right? So does print type exist in the person class? The print type, yeah, print type method. And it does, right? Yeah, it does, absolutely. Right, print type is right here. It's inside person. So far, so good. And then we actually have to call it, right? So we call a.print type, right? Well, A's runtime type is also a person. So it's just gonna run the method inside of the runtime type. Now, in this case, that's here. So same thing, person. So it'll just print normal person, right? Okay, so this one works fine and it prints normal person. Now, what do you guys think? So I just went over the first one, so from now on, like for a lot of them, I'm just gonna go ahead and ask you guys what you guys think. So for the next one, what do you guys think is gonna happen? First of all, do you guys think it's gonna compile? There's an error. So do you think it's a runtime error or a compile time error? Right. So it's because the person is not a student. Yep, you got it. But let's see. All right. Yeah. So actually, I think this is if I'm not mistaken, I think this is actually a runtime error, and it's weird because like the compiler might catch it, but I think it's a runtime error because the thing is that it's trying to cast A to a student, and like so it's saying A is a student. And so what it's doing, so there might be a problem, like the compiler might catch, oh, the A is not actually student, so you can't do that, but I don't think it does actually. So, but it's anyway. So the thing is it's going to cast A to a student, and it's going to check if the student, right? The compiler's job is basically to just make sure this method exists, right? And so if A is a student, which we're told it is, right? We tell the compiler it is. And the compiler is going to check, okay, does the student have the print major? It does, right? So this compiles fine. But when we go to run it, we go through it, right? And we say, okay, cast A to a student. And then at runtime, we're like, wait a second, A isn't a student, it's a person, right? And you can't make a student person because if we go from right to left, right? If we try like, or if we think about it like right to left, right? A student is not, or a student is a person, but a person, right, is not a student. So we can't do like, you can't cast a person to a student. That's not okay. So what that means is that at runtime, we're going to say, oh, can't do that, right? Because the runtime type is not a student and not something lower than a student either. So this, I think it compiles fine, it doesn't run fine. Yeah. Okay, so for the next one, beat up print type. So what do you guys think? That's the next one. Yeah, very good. Yeah, it is student. That's exactly right. It's just going to print student, right? Because what it's going to do first, right, is it's going to check the compile time type. Compile time type B is person, right? We've written that on right here. So compile time type is person. So it's person, and a person has a print type method. But then at runtime, it's going to use the runtime type, and the print type method here is of the. It's going to print student, right? So it uses the runtime type. What do you guys think would happen if, and I don't think this is asked in any of the questions, so I just want to make sure that you guys get this. So next one, just a minute. What do you guys think is going to happen if I remove this? What do you think that this line here, beat up print type, would happen? What do you think would happen here? If I deleted this method here? Oh, well, actually, yeah. What do you guys think? Yeah, so you guys, yeah. So that's yeah, right. It does use the person class as one because a student is a person, right? So it has access to all the methods that the person has access to. So as a result, yeah, so it's weird, but like, yeah. So as a result, like if we did this, it would just print normal person, right? Because it still has access to all of the methods that its parent has. In this case, its parent is person. I mean, well, if it were a private method, it wouldn't have access to it, but as long as it's not private, even if it's protected, like it's fine, it's access to it. Okay, but for the next one, I think someone already gave the answer in the chat actually for it. And yeah, so for the next one, if we look at the B dot print major one, right? The compile time type of B, as someone said, right, this is going to be an error. So actually, wait, before I even go into that, what do you guys think? Is this a compile time error or a runtime error? Right, yeah, exactly. It is a compile time error. You got it. Yep. Very good. And it is a compile time because if we look here, right, The problem is we're going to try and say, okay, does B is a person at compile time? Does a person have access to the print major method? And it doesn't. So compile error. So I think we talked about this earlier, but how would we fix this problem? Right. Well, yeah. I think it might be, yeah. Either way, we're just going to cast, right? Exactly. Yeah. You guys got it. Do exactly this on the next line. Perfect. Yep. So yeah, you're going to cast, and it's exactly this on the next line. And so, like we've kind of seen, right? This is going to work fine because at compile time, it's saying, oh, compiler, by the way, treat B as a student. Now, does student have access to the print major method? And it does, right? Because print major exists in student. And then at runtime, it's just going to make sure that what you said is true. Like it's going to say, oh, is B actually a student at runtime? And it is. So at runtime, this is fine. At compile time, this is fine. And so it works, and it prints the majors of your science. Okay. So let's look at the next one. So c.print type. What do you guys think is going to happen there? So yeah, so let's see. So what's the compile time type of C? It's object, right? So does object have a print type method? No, right. So because it doesn't, right, it's just going to give us a compiler error, right? It's going to be like, oh, can't do that because object doesn't have a print type method. So compiler error. How about the next one? Yeah, it's exactly the same. That's exactly right. Yep. Again, an object doesn't have a print major method. So it's an error, or a compiler error, right? Okay. But how about this one, line 8? What do you guys think? Yeah. So yeah, that's right. I think this one's actually really tricky, but yeah, that you got it. So okay, let's look at this. So what it does is it says, okay, person C dot print type. So it's going to cast C to a person, right? And so from the compiler's point of view, we just say, okay, yeah, I trust you, that's fine. And it's going to say print type. Well, now it's going to say, oh, does the person class have a print type method? It does, right? So this compiles fine. But at runtime, even though we've cast this to a person, C is going to still use its runtime type. And its runtime type is still a student. So it's going to do student.print type. So it's still going to be student. This casting is perfectly fine because even though C is actually a student at runtime, like every student is also a person. So we can still cast a student to a person. There's no problem with that. So yeah, so this works fine. And print student. Okay, how about the next one? Oh, yeah. So basically, we just use castings. And so just so you guys know, I'm reading your questions aloud. So if you guys watch later or whatever, you guys can see it or hear it. So basically, we just use casting to get past the compiler. Yeah, that's exactly what casting is used for. I mean, okay, casting in this sense, right? Like, so for example, if you wanted to cast like an int to a double, that's a different reason. But yes, here we cast just to get past the compiler. That's exactly the reason. So for this one, yeah, it's the same thing. It's still a student because there's still a print type method in a student still has access to a print type method, works fine. Same idea. Okay, so how about this next one? Right, yeah, you got it. Yep. Runtime or compile time? Oh yeah, so it is an error, yeah, so runtime or compile time. Okay. So let's see. So we do person C dot print major. So at compile time, what this is going to say, it's going to cast C to a person. And it's going to say, okay, does the person have this print major method? And it doesn't. So it's actually going to fail at compile time. So even before we get to runtime, this one's going to fail because it won't get to very well. Yeah, so it's at compile time, right? Because it's casting C to a person, and a person doesn't have a print major method. So the compiler's going to be like, hang on, you're trying to use the print major method, which doesn't belong to a person. Like a person doesn't have access to that. Right? So that's the problem. Okay, so it does turn error, but it's like, yeah. Okay. So how about for the next one? What do you guys think? Well, first of all, does it compile? And then, oh, okay, well, there's an answer. Yeah, so it compiles, right? And it runs, like just like you've mentioned, yep. So we cast C to a student, right, which we can do, but we'll see that in a second, right? So first things first, we check the compiler, right? Compiler says, oh, student has a print major method. So the compiler says, okay, you're good. Now at runtime, we're gonna see, okay, is C actually a student? And it is, right? A student is a student. And so we just call its print major method with its runtime type. So its runtime type is student. Student's print major method is going to print computer science. So it prints computer science. And then that's it for that line. And then the next one is just student D is a new person. So is this okay? Can we do this? Oh, that's a good question. So well, I'll talk about that in just one second. Let's do the last question first, and then I'll answer that question you have. But that's a good question. So student D equals new person. What do you guys think? There, right. Because we read from right to left, we say person is a student, and that's not true, right? That's not necessarily true. So that will be an error. Okay, so the question is it possible they would give us a question where they try to cast person to object, for example? So I guess it's possible they could. And actually, okay, let's look at what that could look like really quickly. What if, so what if, for example, we did A, like we casted A to an object, right? So object A dot print type. What do you guys think is going to happen here? Yep. So what do you think? Runtime or compile time? Yeah, that's exactly right. Yeah, because it's going to say, okay, make A into an object. Okay, yeah, so it's compile time. So let's see why. So we always check compile time before runtime because code has to compile before it runs in Java. Other languages maybe not, but for Java at least that's true. So we have to check, we're going to check compile time first. So if it compiles, then we move on to runtime. If it doesn't, then we know it fails at compile time. So we check object, right? We try and cast A to an object. We can totally do that because, well, okay, it doesn't matter if we can do it or not, but in any case, right? Because that's at runtime that we checked it anyway. But if this did get to runtime, this would be fine because A is still an object, right? So this casting is actually okay. But anyway, at compile time, we're just worried about, okay, A is an object, so we call A dot print type. But A, or not just A dot print type, we're trying to call print type on an object. But that's going to fail, right? Because not all objects have print type. So it's going to fail at compile time. I'm pretty sure about that, yeah. But I honestly don't think they'd ask that. But if they do, yeah, it would be like this. Yep, same process. All right, so Let's keep going. We don't have a lot of time in class left, but I think it's really important to go over the inheritance stuff because I think that's probably the most important because it's probably the newest for a lot of you. So, okay, so let's just keep going then. And let's see. So there are 2 more questions. Let's see. Or 3 more. Okay, and then I wanted to get to the coding questions. So let's at 10 o'clock, we'll have like 25 minutes left. So let's just see how far we get. I'll just go over these, I guess, with you guys quickly, and then we can make sure we have a little bit of time left at the end for coding questions. So, okay. Okay, so this one I think is interesting. If you haven't seen it before, then it's pretty hard, but otherwise, hopefully not too bad. So, yeah, so in this one, we say child equals new child. So we have to see what it's going to print, right? So let's actually just go through it together. So we make a child, right? And what's going to happen is child is of type child. So you go into the child class, right? Because we make a new child, right? So we go into the child class and child, the first thing we notice is child extends parent. So, okay, that's good to know. So we go into the child constructor, right, with age. And the first thing to notice is because it extends parent, right? If we want to make a child, I mean, because it extends from the parent, every child is a parent, right? Because it extends from the parent. So because every child extends from parent, you need to, when you make a child object, you also have to make a parent object, right? Because a child has to also be a parent. So you have to somehow, the only way to make an object is to call the constructor. So somehow you have to make a parent. So you have to call the constructor. And when we do that is actually the first line of our child constructor, right? Because it extends parent, there are 2 ways to go about it. If you could write the super keyword, right? And that calls the parent constructor directly. But if you don't write super, then what it's going to do, and that can also allow you to specify which parent constructor you want to go to. But if you don't write that, then it's just going to, by default, call the parent's no argument constructor before it does anything else in this constructor. Because it has to create a parent, right? Because each child is a parent, so it has to create the parent, so it has to call the parent constructor somehow. So what it does is if you don't write the super keyword on the first line, it's going to insert a super right here on the first line. And all the super here does is it just calls the parent's no argument constructor, which in this case is parent. It's just going to print parent constructor, right? But hang on a second, because this is calling the parent constructor. The parent extends grandparent. So before it even does that, here it inserts a super. So it goes up to the parent's parent, which is grandparent, right? And grandparent doesn't extend anything, so you go into the constructor, right? No argument constructor specifically. And it's going to say print grandparent constructor. So the first thing we print is this, and then we go back down, right? Because we finished the super call here, and then we just do this print statement. So it's going to print grandparent constructor, parent constructor. And so once this parent constructor is done running through, we're going to go back to where we made this method call, super, right? And it's going to do this print statement. So it's going to say grandparent constructor, parent constructor, and then child constructor to set up age. And I know that was like a lot, so that makes sense. Oh, so yeah, that's a really good question. So I guess it does. Yeah, that's exactly right. Because every object is an object. So yeah, that would be true. Every grandparent or the grandparent does have an implicit super call to object that does nothing. Okay. So if this made sense to you guys, we'll keep going. I just want to make sure that we have time for everything. So if not, though, I do want to go over it if you guys have questions. But otherwise, we'll keep going. So, all right, so let's just go over this one right away. So first thing, we have to find where our main is. Here it's here, right? So we check our main, right? And we create an animal doggo equals new dog. So again, compile time type of doggo is animal. and runtime type is dog. But we say new dog, so it's going to call the dog constructor, right? And it calls the dog constructor, which we have here. It extends animal. So just like before, right? We have no constructor here, right? So, but one is provided by default for us. And in that default constructor, there's an implicit super. So like we have basically an implicit constructor, which has an implicit call to an implicit constructor. So basically all you need to know here is that it just makes a dog, which is an animal, right? Because no constructor is written, so one's provided for us. Okay, so let me do doggo.print Carl. So just like before, we have to check our compile time type. So our compile time type is animal. Does animal have a print method? And it does, right? So it compiles just fine. But does it run? Yep, because there's a print method, like dog has access to a print method as well, right? So it's gonna say, okay, I have access to a print method, and it's gonna run, and it's gonna use the runtime type, which in this case is dog, and it's gonna print. Sorry, I said something wrong. It's not just doggo.print. I thought it said doggo.print. It doesn't say that. It just says doggo.print Carl. So it doesn't compile. I was wrong. It doesn't compile because it's going to try and say doggo.print Carl. Well, doggo's runtime type, as we said before, is animal, and animal does not have a print method that takes an argument. So there's going to be an error. Okay. That's why it's important to be careful with these. Yeah, inheritance and stuff. Okay, so let's just go over this last question, and then we can go to the programming questions. So I'm not sure we'll have time for all of them, but we'll go through some of them, and I'll like put code solutions or something later. Or we can at least, actually for the coding questions, if we don't have time for them, which I don't think we do, let's just talk about each one and talk about our approach for them. Okay. But okay, first let's do this question. All right, so how do we know if there's class membership? So for class membership in Java, what keyword do we use? Does anyone know? Instance of, that's exactly right. Yep. So here, if we want to know if it's an instance of something, we can't use is and, because that's not a keyword. So we can't do the first one. Fuji, instance of Apple. And so what that's saying is, okay, we have Apple here, right, which extends from object, which then has, so that extends fruits. So in between Apple and object, we have fruits. So object, fruits, Apple. And so, okay, Fuji is an apple, right? So Fuji instance of Apple. And this is going to tell us if Fuji is an apple, which in this case would be true, right? So this one is good, right? And it also tells us true. And then Fuji is an object, we can't write it like that, right? But Fuji instance of object, we can write like this. And this is also going to be true because Fuji is an apple, but an apple is also an object. So a Fuji, because it's an apple and an apple is an object, a Fuji is an object, right? Okay, and then, so this is fine. And then for the next one, we do instance of, you can't write it like this, right? And also, the other problem with this is Apple is a class, it's not an object. So you have to, instance of, you have to call on an object, right? Or you have to use like object instance of class. You can't do class instance of class. So even if there were no space here, this still wouldn't work because you can't say that like a class is an instance of another class because it's not, you have to use the like a particular object, right? Okay. All right, and then G, right? We don't use the extends keyword. Okay, so I know this was a lot, but hopefully everything here is kind of clear. And let's go to the programming questions. And I think actually for this first programming question, we actually went over this at some point, if I'm not mistaken. So let's go ahead and see ones that we haven't gone over before. We can also come back to this one, but let's go and try and check one that we haven't seen before. And okay, let's do question 2 and question 3. Actually, I might have time to write them out, so let's try and do that at least. Yeah. Okay, so let me make a new file. Brand new file. Oh, whoops, should have named it .java. Okay, let me just make another file then. Brand new .java. Okay, now it's a Java file. Now we won't have problems. Okay, so let's do question 2, right? So let's first make our main. So on this website, I have to use class instead of public class, but it would be the same. So in yours, you might write class. So actually, here we just want to write the method. So, but I'm going to write class anyways. We have a main class brand new. Let's just make a main setting. Okay, so our main, and let's just write our method, right? So it's public static int longest sequence. So you guys can read over the problem if you want. And actually, let's go over this a little bit. So it says a common statistic of interest is the longest sequence of some pattern in a list of items. So for example, in football, one may be interested in the longest sequence of consecutive complete passes. So given an array of strings in which each item is either the letter I for an incomplete pass or a number for a completed pass, output the length of the longest sequence of complete passes. So we write a method that takes in a string array, right? And tells us what the longest sequence of completed passes is, right? So how do you guys think we can do this? Any ideas? Okay, I see an idea. So use a for loop that checks each item in list items and adds 1 to a counter each time we find an item. Yes, so you guys are both have, okay, and then the other idea was I would check if the item is I, if not, is a number. So yeah, you guys are both completely on the right track with that, right? It makes a lot more sense to check if it's an I than to try and check what number it is, right? Because if we have to check whether it's a number or not, then we have to I mean, you could do that, right? You could use like try catch, right? And if it succeeds, then you know it was a number. You can try like casting it to an int, for example. And if it succeeds, then you know it's a number. And if it fails, then you go into a catch block. But that's a lot messier than just checking, oh, is it an I or not? So I think you guys are both right about that. That's definitely a good approach. But for this particular problem, right, we don't necessarily need to check. We don't necessarily need to parse the int because we just want to know if it's a number or not, and then find the longest sequence. But I like the idea of using a counter that gets reset to 0 and storing the variable in a different int. So I think that's a really good idea. So let's go submit something like that, right? So I think we might need a couple of different variables, right? So one thing that's important to think about is like what variables am I going to need? Right? So, and I think that someone mentioned that we would need a counter, and absolutely, right? We need a counter to keep track of how many we've seen so far in a row, right? So let's just int completed in a row. And originally, that's 0, right? Because before we start, we had 0 in a row. Now here's where it's a little bit tricky, I think, to try and think about what else we need, right? Because we definitely need that, but if we start writing it, then that may not be enough. And maybe we can try writing and we'll see. And then once that counter gets reset to 0, just store the variable in separate, maybe like a counter in, and then a highest count, store and compare. Exactly. So that's exactly where I would have gone with this. That's perfect. Yep. So let's just go with an approach where this is all we have so far, and we can kind of see where we get stuck and then try and fix it. But absolutely, that would be the right approach. And that's probably what we'll end up doing. So awesome. Yes. So let's just loop through our list items. So for an I equals 0, I less than list items dot length, right? I plus plus. And then if, and like we said, we want to check if it's not an I, right? So list items sub I dot equals, and we want to check if it's not equal, so we'll put a not outside of it, dot equals I. So if it's not this, right? So if it's not equal to I, then we want to increase our completed items in a row, right? So completed, or completed in a row, right? In a row, plus plus. So we're going to increase the number we've seen in a row. But we also need some way to make sure that if we see an incomplete pass, right, or if we see an I, then we have to stop our sequence, right? Because if we kept going forever, then, I mean, that would be a problem because like we don't want the total number of completed passes. We want the number in a row. So once we see an incomplete one, then we want to set our completed in a row to 0. So else, right, completed in a row equals 0. And I saw some suggestions for that originally, and that was very good. Yeah. Oh, yeah. So that'll just give you the opposite value if you use like not and equals to. Yep. So okay. So let's see. So far, right? That's what we have. But now we have a problem, right? Because here, outside of my loop, so the loop finishes right down here, and once the loop finishes, I want to know how many we've had in a row. And the problem is, it might look like I can just print or return completed in a row, but that's not going to work because, like, for example, let's say the last one was an I, right? The completed in a row is reset to 0, but that wasn't the maximum number we had in a row. So it looks like we're going to need some other variable to keep track of maybe how many we had in a row at some point in time. So let's do that. So in maximum, so max completed in a row, and at first that value is 0, right? Because we haven't had any in a row at the beginning. But if it's not equal to I and completed in a row increases, we could put it here. We could like make a check here, but I think it's better actually if we do this here, right? So once we have an incomplete pass, once we have an I, right, then we're going to set completed in a row to 0. But right before we do that, we want to see if maybe our completed in a row, like our completed in a row is more than what we had before, right? Because once we go into this else statement, that means that we're at the point in time when we're breaking a streak, right? So this is kind of like with your project 2, with where you had count runs, right? You want to keep going until like the sequence ends, right? And right when it ends, then you want to make sure like to account for that, right? To see how many you had so far. So at this point, right before we get to this line, right before we assign it to 0, completed in a row is how many we had in a row before our streak ended, right? So at this point, we might have had a streak of the longest possible value. So we might have had like max completed in a row, right? So we want to check, right? If max completed in a row is smaller than our current run, right? So completed in a row. So this is basically checking, oh, is the number we've had, is the most we ever had before this in a row smaller than the number we have in a row right now? And if it is, then we want to make sure our max completed in a row is now equal to completed in a row, right? Because now we want to say, oh, well, that's the number we had in a row, right? If that's larger than the maximum value, that's our new maximum. So hopefully this kind of looks like it works, right? But hang on a second. So what happens? Let's just think, right? Let's go through some cases here. What happens if, like, I don't know, we only have complete passes, we have no I's whatsoever? Then, well, let's see. If we have no I's, right, then we're only ever going to go into this if statement. We're never going to go into this else statement, right? So what's the value of max complete in a row going to be at the end? Yeah, exactly. It's 0. And so this problem will probably remind a lot of you, maybe in a bad way, but hopefully not in too bad a way, a lot of the problem that you guys may have had when you were trying to do your project 2, where you had a sequence of runs, right? And then maybe at the end, you had to make sure that you counted that last run, right? because maybe you were missing it, right? You're missing just the last run. That's exactly what we have to make sure we keep track of here, because if we just run this code, we're forgetting about the last run. So how we would fix that, right, is we would, at the end of the for loop, right, we still want to check if our current run, so if completed in a row is larger than max completed in a row. So we need to put this one more time. And actually, I wrote it backwards here, so let me just write it the same way as I had it before. In fact, I'll just copy this code, right, because it's exactly the same thing as before. And then once we're done with that, right, then that's it, right? Then we can just return it, right? Return max completed in a row. And it's important that we actually do this check, because otherwise we're not ever doing the last run, because if the last pass isn't incomplete, right, if it isn't an I, then we don't wind up going into this else statement. So we never actually account for how long our last run was. So that's why we need to account for our last run outside of the for loop. Okay. And then we just return it. So hopefully that made some sense. And I saw some really good answers about how to go through it as we're going. Yeah. So, and also there was another way, maybe you, even if you think you would have forgotten, like there was another way we could have gone about it. I just wanted to make sure that you guys kind of saw that this was a possibility. So you need to think about things like this. But honestly, if we had put this if statement out here instead, inside of this if statement, right? Then it would have been fine. It would have still accounted for it. We never would have had a problem, because it would have, every time I had a completed pass, we would have checked if now our run was longer. And then we never would have had a problem, right? Because every time our run gets longer, we're checking if it's greater than the maximum run. So that would have been fine if we put it there. But because we put it here, we may have forgotten that. So that's why I did it this way, just so you guys could see. Oh, sometimes you need to remember to check things like that. Okay. So sometimes you can just check that by giving it like test cases yourself. Okay. So, yep. That's this problem. We can run it in a second in the main, but first let's go ahead and do problem 3. And for problem 3, this is a different class altogether. So let's just make a class. Again, I'm just going to write class here. So class lab program, but we need to make a class car, right? Or simple car. That's what's assigned to us. And let's go over the problem really quickly. I'm just going to go ahead and write this out. And so we're going to be given 2 integers that represent the miles to drive forward and the miles to drive in reverse. A simple car object performs the following operations. It drives input number of miles forward, drives input number of miles in reverse, and honks the horn and reports car status. So the good thing is we don't really have to account for the main. The main is already written for us. But we just need a simple car class that can drive forward, drive backwards, and tell you how much you've driven so far, right? And honk the horn. But honk the horn, let's just worry about the other methods first, right? So, well, we need a reverse method, we need a forward method, right? Because those are called here. So we need to make sure that we at least have them provided, right? Drive, reverse, honk horn, report. So, okay. And then what else do you guys think we need besides that? Position. Yeah, awesome. Right. We need some way of keeping track of how far we've gone so far, right? So we need a position. So let's just make that private, just because it's good to have things. All right. So private new position, or I'll just call it private position. Private int position, right? It's just an integer. And then we can, well, we can write our constructor, but we don't necessarily need to write a constructor, right? Because it's just a default one is provided for us, and that's perfectly fine. So yeah, so that's a good question, Sam. So the reason why we need a position is because we need to keep track of how many miles we go forward and how many miles we go in reverse, right? So like at the end, we need to basically give the number of total miles gone forward. So we need a variable to try and keep track of that for us. So yeah, so we don't need to necessarily write a constructor here because the no argument one works fine. We don't actually ever like that. We're just calling the default one. So that's fine. We don't actually need to write it then because it's provided, right? So we just need to write the other methods. So let's do that. So they should be public, right? So other classes can access them. Public int. Or I guess actually it's public void, right? Because these going forward and going backwards don't return anything. They just do something for us. So it's like an action. So they're not returning anything, so they can just be void. So void drive, right? And it takes in an int forward, right? So what do you think we're going to do here inside of this method to make the car go forward? Increase position. That's exactly it. Yep. Yep, right. That's exactly it. Yep. Position plus equals forward. You got it. And then similarly, right, for our reverse, what are we going to have in reverse? Yep, you guys got it. Position minus equals reverse. So you have to subtract. Yep. Yep. Awesome. So that's it for those methods, right? And then we also need a method for honking the horn. So actually, let's look at the example input. I think that might have actually helped. But anyway, for the example input, if we put in 104, the output has to be beep, beep, and car is driven 96 miles. So because 100, we go forward 100 and backwards 4. Right? Forward 100, backwards 4. Oh, you're right. I did, didn't I? Thanks for pointing that out. Yep. I'll just go with rev. But yeah, you're right. That would have been a problem. Yeah, so that's exactly right. Yep, it can be public, right? It has to be public, and it can be void, right? Because we're not returning anything, we're just printing something, right? Because in honkhorn, we just have to print the value. So, right, void honkhorn. And what do you think this one's going to do? If when we call honkhorn, we get this output. So what do you have to do? Yep, you guys both got it. Yep, just print beep beep. Oh, lowercase actually. So. Okay, awesome. So now we're pretty much done, right? We have everything provided or everything written that we wanted to, except for one method, right? And that method is what? What do we still need to use? Right? Based on this code, what have we not written yet? Yep, car status. And in this case, they called it report, but yeah, same thing. Yep, right, we need to write report. So public void report, right? And well, okay, why do you guys think I made it void? Or should I not have made it void? Right, yep, you guys all got it. It only prints, it'll just print. We don't want to return anything here. Yep, we just want to print the report. You guys got it. So in the report, it looks like based on this at least, we're just going to print car has driven, right? So let's just do that. And then what? Then what do we have to write, do you think? Car has driven. Yep, we need to tell it the position, right? Because the position is the number of miles we've gone forward. minus the ones we've got in reverse. So it's the total number of miles we've gone in the positive direction. So that's a good question, actually. Oh, yeah, so awesome. Do we need absolute value here? So, that's a good question. I'm not really sure. Let's just assume that it's the number of positive miles you've gone. But if it weren't, then yeah, we would have to use absolute value. But here, let's just make it the number of positive miles we've gone. So if, for example, if it goes in the negative direction, we consider that to be negative miles, and that's we consider that to be okay. So, but yeah, good question. So we could do absolute value if we wanted to like absolute number of miles we've gone in either direction, but here we're just going to do the positive direction. Good question. So car has driven plus position plus, and then we need miles, right? And so hopefully that works, right? That's our simple car. And that's it, right? It is a simple car. Just has 4 methods, and that's all we need. Okay. And so, okay, hopefully this code at least compiles, but I'll send out the code later, I guess. But I just want, because discussion is almost over and I have to go in a minute, instead of running this code, because I think it runs, even if it doesn't, hopefully we get the ideas here. Let's just go ahead and like briefly talk about the first question, how we would reverse an array. So how do you think we would reverse an array? Any ideas? I know we talked about it in a different week, but okay, well, it's going up again, I guess. Yep. So yeah, absolutely. Okay, I see a couple ideas. So let me read them aloud. So okay, so swap first and last values. That's absolutely an option. And I'll come back to your question in a second, Linda. You can also make you can make a new array, absolutely. Sam, make a new array and have a loop that fills the new one and decrements down on the old one. That is totally a way to go about it. Yep. And so like you can go basically like forward through one array and then backwards through the other. So you're like filling it in reverse order. So totally. Or, oh yeah, and start from last next. So yes. So Sam, that's a way to go about it. And Jacob, yes. So Jacob, absolutely. That's totally a good way to go about it. So one option, right, is to make a new array and then fill it one backwards, like fill the other one backwards. The other option is you could just use one array and go halfway through the array and then reverse the positions, right, of the last position with the first one, the second one with the second to last one. So you only need to go halfway, right, or else you'd switch them back into the original positions. And that's a tricky thing to think about, right? But that's totally a viable and a really good way to go about it. Is you just have you only use the one array, right? And you go through half of it, and you can just like swap the first value with the last one, second one with the second to last one, and so you only need one array. But making a new array, I think, is an easier approach, but both will work. And yeah, Jacob, that was a really good approach. Okay, and so Linda, okay, yeah. So, all right, so this exam, historically, actually, I'm not even sure, wait, if this exam usually has programming problems historically, now that I think about it. So I'm not really sure about this, but anyway, but historically, like this exam can be a little bit tough, right? And the reason why it's tough is because inheritance is like a new topic. And for you guys, especially because like, we just started talking about it, right? So it's tough because like there's a lot of new stuff. So, and usually there's a lot of like, and historically, I think this exam is like all multiple choice, which can be good, but also can be bad because you can't get like partial credit like you can with per response. So I think grades are maybe like a tiny bit lower than the first exam, but like not for everyone. For some people, even if you, especially if you don't do like super well in the first one, your grade can totally go up. But I would guess like average might be slightly lower than the first one, but it's not like a big difference, and it's not too bad. Yeah. But I think, again, that's mostly because it's a lot of new topics and a lot of not really programming problems, so less like partial credit. Yeah. And for the coding problem, so hopefully these two answered that one. And this reverse, we see there are a couple of approaches to take. So. All right, so hopefully that answered everyone's questions. If you guys have any other questions, I'll stick around for like 3 more minutes, but then I actually really have to go. So hopefully everything's okay. If you have to go, then good luck on your exam. Oh, thanks. All right. Bye, everyone.